Hello fellow shareholders, this video is to present you with our chosen molecular target. The significance of the chosen target as well as evidence to support that the molecule should be targeted for anti-cancer therapeutics will be demonstrated. Our chosen molecular target goes by the name of C-FLIP, which stands for Cellular Splice Inhibitory Protein. Proteins, as you may know, are large, complex molecules that play many critical roles in the body. C-FLIP is no exception. This protein activates the AKT cell survival pathway, as shown in the middle image. It can be activated by various stimuli. Things like growth factors, signaling proteins, and chemotherapeutic agents all have an effect on this molecule. C-FLIP is activated by its phosphorylation by protein kinase C at its serine 193 residue. This is basically the action of adding a phosphate which turns on a protein. Once activated, C-FLIP inhibits procaspase 8. This is important for breaking down cellular material and commencing apoptosis. It is inhibited from dimerization and activation. This results in protection against ligand-mediated cell death, what will lead to apoptosis. Apoptosis, as shown in the image in the right, is a programmed cell death where it breaks itself down. C-FLIP was also shown to interact with calmodulin-dependent protein kinase 2, CAMK2. This kinase is in charge of upregulating C-FLIP and also blocks effects of the TRAIL-induced apoptosis. TRAIL, which stands for tumor necrosis factor-related apoptosis-inducing ligand, is a protein functioning as a ligand that induces apoptosis. Thus, by inhibiting CAMK2, C-FLIP activity is reduced and the cell becomes sensitive to apoptosis. This is where the anti-cancer therapeutic part comes in. C-FLIP is known to negatively regulate the apoptotic pathway, and depending on the type of cancer, C-FLIP can be found in elevated levels and inducing their proliferation. This displayed here is just a sample of some of the evidence strongly supporting our case for the chosen molecule for anti-cancer therapeutics. In figure A, there are 4 different cell lines isolated from 4 Caucasian females of varying age diagnosed with breast cancer. Each of these cell lines form a clump of mammary glands called mammospheres. They were each treated 4 different ways. Each treatment showed different results when applied to each cell line. Starting from the left on figure A, the first column was treated with nothing at all. This is their control group. The second column was treated by suppressing C-FLIP. The third column was treated with TRAIL alone. The last column was treated by suppressing C-FLIP and administering TRAIL treatment. Visually suppressing FLIP alone had no real effect on any of the 4 cell lines tested. Treating with TRAIL alone showed an impairment to the cell line on the top and bottom row. When suppression of FLIP is combined with TRAIL treatment, there is a severe disruption as seen by the shape and size of each in the pictures when compared to the original control. Going down to figure 2, there are 2 passages which are showing the qualitative data we saw in figure A in a quantitative form. It also concludes that individually targeting FLIP or TRAIL has some effect, but a joint treatment with both results in little to no mammosphere units being present. In figure C, flow cytometry, a technology used for cell counting, was used with ALDH1 marker, an indicator of cancer cell lines. This technology enhances the quality of HER2 positive breast cancer cells. Thus, only the HER2 positive cell cancer lines were tested. The figure shows the testing of the control group versus the combined treatment of TRAIL and suppression of C-FLIP. Once again, the combined treatment showed promising results in reducing the ALDH1 positive cell populations. So what does this mean for you, the shareholders, you say? The biggest the biggest problem with cancer treatments today is resistance to existing therapeutics. By suppressing cancer with a combination therapeutic targeting C-flip and TRAIL, we will be developing a very effective and novel pharmaceutical at the present time. This means increased profits due to the high demand that will result in the years to come. So now is the time to invest into the development of this anti-cancer therapeutic. I hope we can dedicate a majority of our resources into the newfound project. Thank you for watching this presentation.